Hello, my name is Janessa, and today I'm going to be talking about cation exchange capacity. In this presentation of cation exchange capacity, we'll talk about what is CEC, why CEC is important, and influencing and increasing CEC in your soils. So exactly what is CEC? CEC is a soil's total capacity to hold cations in their exchangeable form. It is defined as the amount of positive charge that can be exchanged per mass of soil. It's quantified in mill equivalents per 100 grams of dry soil, and a mill equivalent is a number of ions which total a specific quantity of electrical charges. Most soils are negatively charged. The negatively charged particles in the soil form colloids, which are thin sheets that have a large surface area. This allows for a very large amount of exchange sites. There are a few factors that determine this, and we'll discuss those in a bit. However, the more exchange sites there are in the soil, this allows for cations to be attracted and hold on to the negative exchange sites. These cations are important because they provide critical nutrients for plant uptake and growth. Some of the most important cations include sodium, aluminum, calcium, magnesium, and potassium, and each of these cations plays a vital role in different parts of plant development. So exactly why is CEC so important? Well, it's important because it affects many features of the soil, which include the soil structure, the available nutrients, how the soil reacts to fertilizer and other amendments, and when those amendments are added, how that affects the pH and buffering capacity. And the buffering capacity is the ability to buffer changes in the soil pH, and it also increases the potential of available nutrient supply in that soil. There are many factors that influence CEC, and here I'll cover a few. First is the soil type. There are many different types of soil that range from heavy clays on one side of the spectrum and have very different mineral compositions down to the opposite side of the spectrum, which is sand. Clay soils have significantly more exchange sites, which means it has more potential to hold cations, while the opposite is true of sandy soils. Second is organic matter. Organic matter significantly increases a soil's cation exchange capacity, meaning it provides more exchange sites. Organic matter includes the living animals such as earthworms and other insects. Also is decaying matter such as leaf litter and plant and animal detritus at differing stages of decomposition, as well as other tissues. And lastly are the soil microbes such as bacteria and fungi. Lastly is pH. pH is extremely important because it controls the chemical forms of nutrients available to plants. A pH of 5.5 to 7 is the best for crop production. I hope that you've learned a few things about CEC and how paying close attention to the CEC values in your soil can help you better understand your soil's needs and improve your crop's potential production. Thank you for watching.